So in this question, we have like, we're given a list of integers, and we're given when 15 is appended to a list of integers, the mean is increased by 2. And when 1 is appended to the enlarged list, the mean of the enlarged list is decreased by 1. And we want to know like how many integers were in the original list. And yeah, this is like also a very common kind of question where they're going to give you some list of integers, and they're going to tell you, oh, suppose we add a number into the list, something happens to the list. Let's say maybe we take away a number, then something also happens to the list, and things like that. It's like a very common kind of question. So I guess like the trick to these questions is like we can use variables, right? So we can say like let M be the mean of the original list of numbers. And then like we can let N represent like the number of numbers in the list. So number of integers in the original list, right? So we got two variables. So M is the mean of the original list of numbers. N is the number of integers in the original list. So we're given that 15 is appended to a list of integers, and the mean is increased by 2. So originally, if the mean of the numbers is M and there are N numbers in the list, then just by definition, the sum of the numbers, so the original sum of the numbers is going to be M times N, right? So if we were to append 15 to the list, that means the original sum is going to increase by 15. So the new sum is going to be Mn plus 15. And we're given that the mean, when we add 15 to the list, the mean is going to increase by 2. So M is going to increase by 2. But the number of numbers N is going to increase by 1, right? Because like you got an extra number in the list. So you get Mn plus 15 has to equal M plus 2 times N plus 1. And then like we're also given another condition, which is like when 1 is appended to the enlarged list, the mean of the enlarged list is decreased by 1. So when 1 is appended to the enlarged list, right? So when we add 1 to the list, the sum of all the numbers is going to become Mn plus 16. Then the mean, we're told that the mean is going to decrease by 1. So the mean was M plus 2, so the mean is going to become M plus 1. And then the number of numbers in the list is going to increase by 1, so times N plus 2, right? So now we get like these two equations and two variables, and we just want to solve for like, you know, the number of integers in the list, which is N. So basically we can kind of like expand out the first expression. We can like expand it out, right? So you get like M times N there, like M times 1, like 2 times N, and like 2 times 1, so plus 2. And then from this second equation, you can also expand stuff out, right? You have M times N, like plus 2M plus N, and then plus 2, right? So we get like those equations. So from the first equation, we can kind of like cancel an Mn on both sides. So from the first equation, we can cancel off an Mn on both sides. We can subtract 2 on both sides. So we get M plus 2N equals 13, right? So we get M plus 2N equals 13. And then from the second equation, again, we can cancel off an Mn on both sides. And we can subtract 2 on both sides. So we get 2M plus N equals 14. And then we get like two equations and two variables. So this is just a system of equations which we know how to solve. So you can use either substitution or elimination. But like maybe elimination will be easier. So what we can do is we can take this first equation multiplied by 2. So we get 2M plus 4N equals 26. So we can now like do this equation minus this equation. So doing that, we can cancel off the 2M's. So on the left side, we get 3N. On the right side, we get 26 minus 14, which is 12. So from there, you get like N equals 4. So that tells us that there are like 4 numbers in the original list. So the answer is choice like A. Yeah, so the general idea for this is like, this is like the general idea for these kinds of questions where you want to let like M be the mean of the original list of numbers, let N be the number of numbers in the list. Sometimes it might be more convenient to like instead of defining m as the mean, maybe you can use a variable like s to denote this actual sum. But in this case, like we used like m and n as these variables, right? And then like basically using the information it gave, we can construct these two equations like just by logic. So like, you know, mn was the original sum. When we append 15, we get that. And then we can build these equations and then just solve them, I guess. So yeah. So if you like knew how to like construct the equations, then like this problem wasn't like that bad.